So on our Chapter 12 activity, I have provided you with data for 17 infants, and the first column is just the infant ID, so that's not so interesting. The second column provides the gestational age in weeks, and anecdotally, pregnancy generally lasts 9 months, so 9 times 4 weeks is 36. And a month isn't exactly 4 weeks, so this goes a little longer than that. But those are the time that the baby was carried, and then the birth weight in grams. And just a reminder that there are 454 grams in a pound, and we can look at those weights. Now, notice that this is sort of a low birth weight, and this is a shorter gestational age, so that would indicate the baby might have been born prematurely, and it had a lower birth weight. Let's find the highest gestational age in this list. Looks like it is here, so I'll put a star there. And where is the highest weight for the babies? Is that also this one? Okay, so it's a little hard to see at a glance whether increasing age leads to increasing weight. It will be easier to see after we graph. And I have the steps for entering your data into the calculator in our slideshow, and this is slide 27. Okay, so the process will be to go to Stat, Edit, this is about scatter plots. I thought I had a slideshow for entering it. Well, I'll show you the process. So Stat, Edit, and I have already entered this data into L1 and L2. It's a little tedious, but I did it ahead of time. So there it is, 34.7, 1895 grams, 36 weeks, 2030 grams, and so on. So I carefully put those in. And so I've got this completed. Then we go to second stat plot and press enter. So right now all my plots are off, and I need to turn plot 1 on. It looks like I've got 3 box plots going, which I don't want right now. So I'll turn this on, and then I'm going to turn this into a scatter plot instead of a box plot. So step 3 is to highlight the scatter plot. And then step 4 is to tell it to look in L1 for X and L2 for Y, which is good, that's what I want. And then for mark, it doesn't matter, but I like the little boxes. And I'm going to change this color to green. Okay. So now I've got all my settings for my scatter plot. And then go to step 6 says press Y equals. So if you have anything in here, you want to clear it out. And then press the zoom key. And then zoom 9 will make a window based on what we've selected. So that's the scatter plot for the baby weights. As gestational age increases, the babies are getting heavier and heavier. You can press window to see the scaling of the axes. So if I press window, I can see that the minimum and the maximum X, 28 and 43. So I could change this to be 25 and 45, and then scale it by 5-week increments. Maybe 4-week increments would make sense, because then it's more of a month thing. Let's see how that changes the graph. Okay. And notice that I'm not starting at 0 months, although I could. Let's see what happens if I start at 0 months. Graph. See, babies are not going to be born. They're not viable. This is even a premature baby right here. So all the babies are going to be in this range. So if I want to do that, I'm going to scrunch up all my data on the right-hand side. So I can go back to having it be 25 and 45, and that looks a little better. So yeah, there's my graph. And I'm going to go back to my questions here. One thing I thought of doing back in the stat edit was to go into L3, which I left blank for this purpose, and just say I want that to be second L2 divided by 454. And that gives me the weight of the baby in pounds. So I thought that would be kind of interesting to be able to see. So that heaviest baby at 42.4 weeks was 8.5 pounds. And I've certainly had friends who had 10-pound babies. I am not seeing any 10-pound babies in this study. Looks like 8.5 pounds was about the heaviest baby in this particular study. And wow, that premature baby was only 3 pounds. Okay. So what is the independent and what is the dependent variable? Well, y is the dependent variable. It depends on x, and that is the baby weight. It's dependent because it depends on age. And x is equal to the baby's age in weeks. And we could say that this was in grams. What relationship do you predict between the two variables? Not so shocking. As age increases, weight also increases. Notice that I talked about x first, and then I talked about the effect on y. And that's typically how we phrase these. Make a possible sketch. Well, it's too late. We already saw our scatter plot, but before you do a scatter plot, you could just say, oh, if x is baby age and y is weight, then I would expect that the older the baby gets, then it's going to weigh more. So we'd expect something like that. And sure enough, our graph looked something like that. So we already did this step. And is linear regression a reasonable idea? Yeah, this would be fine best fit line. Find the regression equation. So now we're going to go through the regression process. Stat, calc, linreg, enter. I think I have these instructions here. This is on the 4th page of the notes sheet. So this is the scatter plot instructions, and then here are the linear regression instructions. So this will help you later if you forget how to do the process. Well, I guess I can keep this handy here for now. So from the home screen, second mode, so second quit, stat calc 4, so stat calc, and then 4 for linear regression. And then it says to call L1, L2, and Y1. So L1, L2, I'm going to clear that out. I do not want a frequency list. My TI-84 doesn't ask for that, but this is a TI-84 plus, so I guess it's a little different. And then where do you want to store the regression equation? You don't have to do this, but if you want the line to show up on your graph, then you should tell it to put the regression equation in y1. And here's how you tell it. You press vars, yvars, enter for function, and enter for y1. So again, vars, yvars, enter, enter. And then you can press enter. So it's taking the x's from L1, y's from L2, ignore that part, and then enter. And now I have my regression equation, which I'm going to write down on my paper. And if we press graph, the line shows up with our data. Oh, that didn't show up. Okay, so stat calc for, I have to do this again to retrieve my regression equation. Enter, enter. Okay. So going back to page 1 or page 2 of your worksheet, I'm going to write down the regression equation. Round a and b to the nearest whole number, write a plus bx here. (180) x plus negative 4020. And before I was writing the standalone number by itself and then putting the number beside x after that. These two are the exact same equation, so I could just use b plus ax, which is my preferred way, but this is equivalent, and this is what the calculator gives me. The coefficient of x is always the slope, so that is 180. What is the interpretation of 180? Well, that means that y increases, so the weight increases by 180 grams for each additional what? Week of gestation. The constant term is the y-intercept. The y-intercept is the value, is the y value when x is 0. So this is the baby weight at 0 weeks of gestation. And this is saying that it would be negative 4,020 pounds, which again doesn't make any sense. You can't have a negative baby weight. And so don't worry, y-intercept often doesn't make sense. The next thing it says is to write the value of r. And my calculator did not give me the value of r, but in order to have it r, I need to turn on the diagnostic. So you should only have to do this once. You need to go to second catalog, and then you scroll down until you get into your D's, diagnostic on. So I guess the r and r squared are the diagnostic. Cool, now it's on. So if I go through and do my stat calc linreg process again, I've already stored the regression equation, so I won't bother with that this time, and I'll just hit calculate. This time it actually tells me the r and r squared values. So r, I'm going to keep 4 decimal places, is 0.8175. And this indicates a pretty strong positive correlation. Now R squared is 0.67, and this means that 67% of the variation in Y, or in baby weight, is explained by gestational age, X. Use regression to predict the birth weight of the baby born at 33 weeks. Okay, so now that we have this equation here, we're actually going to use it. We're going to plug in x equals 33 into that equation. So y is equal to 180 times 33 minus 4020. And let's work that out. Oh, you know what? I can do that on the graph. I can say second calc value, x equals 33, enter. And it says 1935. Let's see what we get with this method. 1935, what's 180 times 33 minus 4020? That gives me 1920. So a little different, probably maybe because I rounded off those equation values a little bit, and so when I use my calculator, I get a slightly more accurate answer, but it's still in the same ballpark. So this is grams. Give your answer with correct units. We're predicting the weight of a baby born at 33 weeks. And then if we use our regression equation to predict a baby born at 44 weeks, then let's see what happens with 44. 3920 according to that. 180 times 44 minus 4020. That one just says 3,900 grams. Anyway, it's significantly heavier. Using the regression equation to make a prediction for an x value within the data points is called interpolation. Interpolation. And how did I know that 33 weeks was inside the data and 44 weeks is outside the data? Well, we didn't have any babies that were at 44 weeks, so that's beyond the scope of all this data. 33, it's on the low end, but we did have a data point lower than that, so 33 is technically within the data that we had provided to us. So that's why that's considered interpolation, and this one is considered extrapolation.